So welcome back everyone, my name is Akshay and welcome back to this GFG POTD streak of day 152. So today's question name is string RP or PR asked in Google and the tags you can see as strings, GUI, JavaScript tags and algorithms. Okay, so let us read the question. If you have read the question and were able to solve yourself, that's well and good. I'll just uh, read it together and then solve it via different approaches if possible. So given a string s, in one operation you can remove pr from the string s and get the amount x. Okay, so अगर आप pr remove करते हैं, so you get the amount x, and if you remove rp, you get the amount y. So what is the thing that we have to find the maximum amount you can get if you perform zero or more such operations optimally? Okay, so substring of string is different. Okay, after removing pr or rp, the should remain the same. Okay, so let us see the first test case how it is saying. So we have this string as a b p triple p and triple r, right? And for x it is saying 5, which is the string associated as pr, and the y it's 4, and the string associated with this is rp, right? So it is saying that remove pr from here. It's a part of the string, then remove it, and you have this value as 5. Then again remove this pr, right? So when you remove this pr, right, so your string will be converted to a b p p r r. Then you again remove the pr, so now it will be 5 plus 5, right? And now the string will be converted to what? A b pr. That's still present pr, so remove it again. It will be 5 plus 5 plus 5, right? So it will be 15. और अब आप इसमें से कुछ नहीं रिमूव कर सकते हो, बट लेट्स से हाँ कुछ नहीं, बट लेट्स से अगर हमारे पास ये यहाँ पे एक आरपी एक और होता, राइट? So you will have RP here also till all these three PRs are removed, right? So then you can remove the RP here because PR is no longer a substring of this string, right? And then you can plus 4, right? Okay, so we saw that how the 15 is coming. तो ये क्वेश्चन है ग्रीडी अप्रोच है. ग्रीडी क्या मतलब होता है कि लाइक ग्रीडी लालची. So the first thing you need to do, जो आपको दिख रहा है, like the maximum profit you want to make, right? Just start brutally in that direction, right? So मैं देख पा रहा हूँ कि you need to find the maximum cost, right? If you have to find the minimum cost, then I would have started from the cost which has the lowest weightage. But the question says you have to find the maximum, so that is why I'm starting from the highest weightage, right? So if I write so in this case you can see that it will be 15, right? And suppose the RP was also present here, right? Then it would have been 15 plus 4, that is what? 21, right? So let us verify this thing as well and then proceed ahead with some more examples. Yes, so 15 plus 4, it's actually equals to 19, not 21, right? So let us confirm this thing. So I have run the compilation without writing the code, and you can see for this substring where we include the RP, then you have the answer as 19, right? So let us see for the second test case as well. So both the costs are similar, right? So either you search for PR or either you search for RP, both will remain the same. But you can see that there are two instances of PR, this PR and this PR, right? If you remove it, then X will be associated to PR. It's given that X is associated to PR and RP is associated to Y. So after removing two PRs, you have the string as PPTP. So there is no other instances of RP or PR, so the total cost will be 14. So let me give you some more examples and then we'll proceed ahead with the code. So I mentioned one more example for you to get a very clear understanding that how this is a greedy one, right? So let's say you have this string, this thing RP, PR, and PRP, right? Write this test case in your copy, and one more, and you have this cost associated. X is pointing to PR, which has the removal cost as 7, and Y is associated to RP, which has the removal cost as 9. So let's not approach via the greedy. Like if you have approached the greedy one, then definitely I will first remove the instances which have the maximum cost, right? So let us not do that thing and then see how the answers differs or not. So let us move with the lower cost first. So let's find the instances of PR. You can see there is one instance of PR and there is another instance, right? So that removing two instances will give you the cost 7 into 2, 14, right? And then the string will be converted to RP and P, and then you can see there is one instances of RP, so we'll remove that one. So 14 plus 9, it will give you 23, right? So that is the thing that you have followed a linear approach, that whatever the X and Y was given, you just followed that. But that is not the answer which you will expect, right? So let us go with the directions where we have the maximum. So if we see that the Y has the cost 9 associated with, right? So let us find the instances of RP. So you can see there are three instances, right? So 9 into 3 will be 27, and then the only remaining substring left will be P, and you cannot reduce any further either with PR or RP, right? And you can see the answer of this string will be 27, right? So we are clear here now, right? So what we have to do, we have to make the string, right? And we have to search for instances of highest cost substring for substring when writing SS. And once you did this thing, then you have to do the same thing, search for instances for the second highest cost. That is the remaining one. That is the let me write it, second highest cost of the substring. That is, suppose if you ran for RP here, then you have to do for PR. And suppose if you did for PR, because PR cost was more, then you have to do for RP, right? So that's the thing. But again, the brute force technique will be that if you, I do not know how greedy and what are all this approach. So brute force will be that you forms all the substring, that form all substrings, right? And then remove it and do as the question is saying, right? To forming all the substrings will give you a time of 2 power n, and the n has the constraint in such a manner that if you do 2 power n on that, it will, yeah, it's 10 power 5. So 2 power of 10 power 5 will be definitely greater than 10 power 8, right? And it would be a more complex approach that forming all the substrings, right? As I already told you, whenever the sub array or substring question comes, you can, the brute force is very simple, form all the substrings and do as the question says, right? So forming will be again 2 power n, and then doing as the question says will again be a complex task, right? So it will give you TLE, even if you're able to code it, the approach is right, but it will give you TLE, right? The second approach is the greedy one, which we discussed, right? Okay, so let us do the first step. First step is let's decide which one is the highest, which one is the highest cost. So let me write it like this. Let's decide that which one is the highest cost. Let us code this step and then we'll move forward. Okay, so what can I say is that I am having this X, right, which is representing as of now as PR, right? And let us store this string in another string, that is S1, and then we have given the Y, which has the associated string RP, but let us store this string in S2, right? So let us do this thing. So I will write string S1 is equals to what? Uh, it is associated with PR, right? And then string S2 is equals to RP. Yep. Right. So if X is greater, right, then you don't have to do anything. You will just proceed on with forming the PR substrings in your problem. But let's say that if X is not greater, right? Let's say that Y is greater, then you have to the search the strings for the Y, right? So let us just swap this thing, है ना? So instead of writing if X is greater than Y, first search the PR and then search for RP, what we do is that let us swap it. If X is greater than Y, then then it's already handled, and if it's not, then let's just interchange the strings, right? And that is the reason we have stored that PR and RP into one particular string. So let us swap this thing. So I will pause the video to swap it. Yeah, so I have swapped it. So what it is doing is it is handling the case that whenever, because I am writing the code for always starting with X, right? But let's say suppose Y has the higher cost. So what I'm doing, I am transferring the Y cost to X cost, swapping the Y cost to the X cost, as well as swapping the Yth string which has RP to X, right? So that's the thing. So now what we have to do is, now we have to do for, or let's say if I write the comment, then we know that now we have the larger cost, the X has the larger cost in any case, and the string associated with name is S1. Yep, I've written the comment as well. So ठीक है यार. So now what we have to do next is, now we have to find the substrings of suppose if we take the first case, then the X has the 5, then you have to find the substrings of PR, right? So what we can do is, let me clear the screen. So I have to find the substrings of X, X, and X is pointing to which substring? It is pointing to PR, right? Okay, so what I'm saying is that let us maintain a stack, right? Let us maintain a stack, and in stack what we'll do is, let's for I, we will start from iterating from this point to this point, and for I equals to 7, I will see that if my stack size is greater than 0, So in the first case, it is not greater than 0, right? So let us push the first character. For I equals to 6, I will compare. I will see that if the stack size is 0, but it is 0, but I need to compare that this character, right? The first character is P and the second character is R, right? So I need to compare that my current character, if it is equals to P, right? Then only I will check that. I will check like this, that let's say R, I will keep on pushing it, I will keep on pushing it, and my current character will come as P, right? So now I will check it that if it is equals to the first character of our substring where I need to found, right? So it will say yes, you are at this point for I equals to 4 and you have the same character as the first character in your the substring that is needs to be found. So what I will do, that I will check now, this will be my first thing. The second thing I will check that if st.peak, if st.peak is equals to the a of, let's say 1, not a of 1, we have named this substring as s1, right? So I will check if it is equals to s1 of 1, that is the second character. If it is, then we will pop it, right? And when we pop it, we will maintain one answer thing, we will add the cost, answer equals to answer plus x, and now the answer has become 5. Similarly, the next p will come, right? These two conditions will again satisfy, then we will again pop it and answer will be now 5 to 10. Then for I, this is for I equals to 3, this is for I equals to 2, again p will come, and you can see that these conditions again satisfy and the r is there, so we have to pop this r again out and answer will become 15. Now the stack is empty, the stack is empty. Now let me use this space here, stack is empty, and for I equals to what, 1, the character is B, right? So nothing is, the first character is not itself matching with the substring, so no need to check any further things, just put the B there. And for then and then for the last iteration, that is I equals to 0, we put the A. So let us suppose that RP was also here, let us suppose that PR was again here, right? So then R was again have been pushed, and for this integer the P will come and it will see that P matches to the first character of S1 and R again is there in the stack, then it will be again popped out, right? So that's the thing. So I highly recommend you guys to stop this video here now and pause this video here now and try to code this approach by yourself, right? Okay. Okay, so I hope you are able to do it. If not, let's do it together. So first let's make a stack and I will run a for loop from the right to the leftmost part. Let me do that and then we'll resume it. Now the main thing comes that we have to compare, right? The first condition that we're comparing is that if my current character, right? So let us store the characters as well. So the characters that is need to be compared with. So first of all, my current character will be there, which will be nothing but the s dot char at I, right? And then there will be this first character of s1, right? So I will say s1 dot char at 0, right? And this will be the second character which I need to check it from if it is present in this stack using the peak. So I will say second is equals to s1 dot char at 1, right? Now what I need to check is that first of all I need to check if st dot size should be greater than 0 to do the comparison, right? And then I have to check that if my current character is equals to the first character of our substring, right? So I will write that thing that if my current character, if it is equals to first, right? It equals to first, and that's the case, then let's match the second character as well. So I will say, and the second character would be present in our stack, right? So I will check if st dot p is equals to second, right? That is what I have shown you in the dry run, right? So if that's the case, then you have to do st dot pop. You remove that character from there, because once you find a substring which is a part of your original string, you have to remove it from there. And the second part was to increment your answer, right? So this is the part where we are processing the x, right? So I will take the x, and in all the else part, if it is not matching, if it is the first string, and if it is the stack is empty, right, then we just have to push the current character. So that is it. Yeah, so this is the thing, this is the code for 50 to line number 60. It is handling for the cost which has the maximum weightage, right? So let's say that all the instances of one PR, let's say PR has the maximum cost, so that is solved, right? But then again, let's say after reducing the string, we again have a second cost, the RP is remaining, in your string, right? That is what we have seen here in the first test case. We removed all the three PR instances from here, but we can see clearly that RP was also there in our string, right? For this test case, and we have verified this thing as well. The output was coming 19, right? So that means we have to do the same thing again, but for the second highest cost. That was the intuition, right? You can see here the step 1 and step 2. So what we're going to do is that the remaining string is present in your string. That is definitely true, right? You can see for this A, B, P, 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 and RRR, this PR, this three instances was removed, and then the current string, that is AB, is present in our stack but in reverse order. So let us pop out all the elements from the stack, and then we will repeat the same process that we did for X, but we did for X, we will do same thing for Y. So let me run a while loop, popping out all the elements from the stack using a string builder, and then we will continue. Hmm. So that's what I have written. The remaining string I have popped out from this stack, right? And I have used a string builder because you know why to use a string builder, because the appending time complexity is O of 1. While if you use an empty string and try to add it with the plus equals to operator, then you will always get a time complexity of O of n. I have explained you multiple times in this my POTD speak. So using that thing may give you a time complexity as well, right? uh, TLE, yeah, TLE as well. So this is O of 1 operation, that is we are using string builder, but we are using string builder, you have to convert it into string. You have to use this remain dot, not remain. Remain is the remaining is my conventional name I have given because the strings are remaining, right? These are all the strings that are remaining from the above pre-processing. You have to call to string, you know these things, right? So now we have to do the same thing, but for the another cost. Since there are only two costs given, so now we will process it for the okay. So let me copy it, and then I will paste it here. And the comment I have written, so the remaining string we have to check for the other cost, that is y, right? If there are any instances present, remove them and associate the cost. So cost is now here y, so I will replace it with y. And similarly now the string will be s2 here. So let me replace it with s2, right? All the things will remain same because we're doing the same exact thing just for the cost y, right? And at last we will return the answer. And I have made this answer, I have not made this answer variable, so let us make that variable as well. So long answer is equals to 0, right? So let us compile and run, and we will see for ourselves. So yes, the output matches one, yeah, it matches, right? So we have made a stack, we have made a long answer variable, we process it for X, and then we reverse, the remaining string was present in the reverse order in stack. So we popped it from the stacks, we stored it in remain, and then we update those strings again to our original string S, and we ran the same exact code which is present above, but for the case Y. So what will be the time complexity here? Earlier it was 2 power n if we consider the brute force technique, but now here we are just traversing 2 times, right? For the s dot length, so it will be O of 2s, and the space complexity will be, we are using a stack for the characters, so it will be O of s. S is nothing but the length of the strings, and s, the constraint has it as 10 power 5, so it will definitely get submitted. Let us submit the button and we'll see for ourselves. So great, it has been successfully submitted, right? So let us do the things as he had asked me to do the same thing in the C++ as well. So let us copy the code from here and paste it in C++, right? And we will see that what are all the changes are done. So I will, let me make the changes and then I'll directly show to you because the video will go long unnecessarily. So I made the changes in C++ as well. So instead of capital S string, you have to write just small caps. The swap, you can just replace it with swap of x comma y, but in Java, swap function doesn't work. So for long answer, you need to declare long answer. For stack character, st equals to new stack in Java, it's very simple to declare in C++, just stack, and like this, maybe C++ users will able to relate more well. And I'm also learning. So this is the first for loop. We did the same thing. So the first characters, and then we did the same for loop. We reversed the strings for the remaining one. Did the same for loop for the cost associated with y, and then we are returning the answer. So let us compile and run. Let's check it that I validated the code in a uh, proper manner. So let us hit the submit button, and then we will end this video here. So great, as you can see, all the test cases have been passed. So that's it for today's video. Now let's meet in the tomorrow's POTD streak of day 153. Till then, you can I have mentioned the links of the DSA as well as my Instagram channel and LinkedIn. You can connect me anytime, anywhere for any doubts and guidance if you may have. Till then, keep learning. Bye bye. Take care and keep going. Bye bye.